Yeah, I was just asked to a presentation this morning. So after like I chuckles, like probably it's too heavy for you guys. But I seriously presentation. Our company is called TieSet. Basically, we are providing a platform for like efficient machine learning training processes. So let me kind of go through what the real program is in machine learning. So if you are involved in machine learning, creating like models, applications, probably everybody knows like the cost to create machine learning application is super expensive. Because you have to kind of already purchase a lot of GPUs by NVIDIA or something, which easily costs like 10K or something. And you have to hire machine learning engineers like 200 or 300K a year. You have to optimize the machine learning engineers' time and also deploy to the product. So this is the problem that we are basically solving. Basically, you have to spend a lot of money and time to create machine learning applications like that. So now you see, like, you have to spend like 10 weeks to create, for example, like robotics arms and stuff, which is super expensive, and speed of training is very slow, and it's kind of really complicated. But our platform can really resolve this problem. You have to make it short. The training time can be like 50% less or 90% less even. Which is kind of past deployment of machine learning models. This tool is used in some industries right now, such as like insurance, and also industry like manufacturing robotics, and also healthcare. So in a nutshell, what we do is just optimize the usage of enterprise data for training machine learning model at scale. You can do it on the edge side or on the cloud platform. And also you can secure the private data to quickly integrate new data to get the kind of data application always updated. Let me go through the case studies. So one of the interesting applications is robotics arms, where like you basically have to create a robot to grab everything, like ball, boxes, balls, or ducks, or teddy bears and stuff, And actually, it takes a lot of time to create a robotics arm to grab everything, because each task of grabbing something is kind of independent. So it's way more efficient to integrate all those learnings. So that if you use a platform, you basically run the task of like grabbing whatever, like boxes and stuff, and then you just integrate all the learning results. So you see our result here. It's 80% accuracy with just spending like 1 day, right? Rather than spending 11 days and still accuracy 50%. So that's kind of magic that we have with one of our customers. Another like example is like you have a drone application. You have to detect where the construction happens right now. But sometimes you do construction in the areas with gas pipelines and things, which is strictly prohibited because it's super dangerous. Usually you have to go there and buy a truck and detect this place is not allowed for construction. Use drone to detect where the construction is happening, and then just Brazil, like in Rio de Janeiro, like you have something going on, and you use that data model to detect something else, like some other cities, and just like make the process efficient, and then you cut up the training time like 80%, something like that. So this is autonomous driving, where like each person's stress level is different, and basically it's more like a privacy program of not being able to share the personal data. All the data is in the car right now, and you basically learn what people want to kind of listen to, or basically enterprise application, or entertainment application that you can handle. Or in this case, we detect people's stress level. So some people feel stressed while like driving too fast. Or some people, like younger people, basically okay with higher speed or something. So we detect that stress level to optimize the driving for each car. Yeah. So this is healthcare. But the same thing happens like hospital data, patient's data is super sensitive. You can't really share data. So this framework integrates only the learning resource to make it more efficient. But probably this might be a little more relevant to like one of the customers that we are working with, like insurance company that we're working with. I heard that like in Brazil, like that company has second biggest share in auto insurance. I guess you probably guys use like car insurance from Japan. And that's the company. So basically, they have a lot of data dispersed at each like retail stores and stuff. You would never be able to share data, but there should be the way to kind of optimize the discount plan for each customer. In this case, it's more like financial fraud detection, and there's a wrong transaction happening somewhere, especially bank or insurance company ABC. And the same thing happens, like you, by not really sharing data, you can maximize the detection rate up to like 90% this time, or 94% actually, and then you basically save $659 million. It's a lot of money you can save by really optimizing the quality of data. Yeah, so that's it.
So are you acting as like a trusted third party for all the data federation going on? Like if they can't trust each other, they can't share this data with each other.
Yes.
Why are they able to share it with you?
I mean, in this setting of finance, like there should be some constitution that like angry participants programs, say for hospitals, different hospitals are there. But there should be some group of like organizations that kind of collect data. That's probably the party that they have. But we are not focused on these areas because there are so many regulations. Right now it's a little bit slow in terms of the national data.
I think for this specific example, I'm just curious how you're going to deal with it, because hospital is sharing the data with you, right?
So the thing is we don't collect data. It's only the intelligence.
Okay, so their training is there, they're sending the weights.
Small scale. So basically, like that concept should be a privacy preserving AI goal right now. So that's the consensus right now. But there should be a way to make it more secure and private. So research might say it too.
So like the reason you become more efficient is put a drone out, bring them back, load that data in a computer, feed your AI system. And the other one, you would like having all those drones at the same time, live passing the data to the data? Like automatically I'm connected to a bunch of drones
Yeah.
and everything is feeding the system?
In this particular example,
Yeah.
drone is just collecting data. And like I said, send the data to some platforms, like computing platforms. But still that is to automatically distribute the updated like AI each drone. So, and then, but you don't have to collect all the data into one place. Like in one city, you create some server, you have some server to collect data from drone. In another city, you have another kind of instance. And independently kind of learn the data in different cities. And then, but we have stable to orchestrate everything. So you can do like machine learning power.
So you can conduct the views for fire detection in California, like you send a bunch of drones, and then you're able to like scan a huge area of forest and detect places where there's potential fires.
Yeah, exactly. You can use it for use that model to detect under fire happening in some other cities too. But something is slightly different. We know like humidity or something, whatever it is, and you can handle other things. The thing is, model is always calculated. So that
Is there a limit of how many systems you can connect to?
that's our strength. It's like it's unlimited because we use all scaling framework.
So you could put 1,000 drones and they all would all be feed to that system or something?
Yeah, probably more than that.
Okay, yeah, I mean, if it's a limit, yeah.
Okay.
Thank you.
Does benchmarking compared to raw in the US versus other platforms?
Benchmarking on
The performance says the cost is 50-60% more. How did you come up with that? Because everyone's trying to create tokens and trying to figure out like how do you come up with that? Do you have any comparison?
yeah, we have actual numbers. So actually, in terms of cost, there are so many factors to consider. Like, so one of the things that we compare is like use AWS and GPU resources. Like big one costs a lot, small one costs less. And by saving like 70% of the time, you don't have to use that huge machine for next like 10 years or something. Calculations based on that. Am I answering your questions?
You know, is there a platform like Rock, and then it depends on like what kind of LLM you use, and one of like less parameter, more using the straw, so when you say it costs less, I want to see some sort of comparison from A and C, and then this is cost 50% less, versus you're saying I'm going to spin off a smaller machine, so everybody could do that, I'm not getting where you're getting 50 to 90% cost.
I think there are so many factors like ARM's will be small enough to run on small GPUs and stuff. So I mean, basically, it depends here if you use Llama or something, and the cost itself is very high. So one of the examples is to use like Llama 7B in smaller instance and then just run it for like a couple weeks and stuff. That's our kind of ongoing use cases. Because 760 or like huge Llama costs a lot to train. The same analogy can be there to be applied. But if you can save like 70% of the time, then you can easily apply that framework to bigger combination. Any other question? I gave a lot of factors. in terms of cost. So calculation is very hard, very expensive.